Our objective today is to write functions using function notation, evaluate, and graph functions. This first slide I don't want you to write down. I just want you to review what is an independent variable and a dependent variable. An independent variable is your domain, what you're substituting into the function. So here's some values, 2, 3, 4, 5, and 6. And then we have our function down here in the box, f of x equals x plus 4. And once you substitute, let's say, 2 into the function, 2 plus 4 is 6. So what you get out is your range or your dependent variable. How we write this notation is f of x. So this first order pair that we just talked about, if I substitute 2 into the function, so 2, what I got out, when I substitute 2 plus 4 in, is 6. And then we would do the same thing for 3. We would substitute 3 in, 3 plus 4 is 7, and then continue there. What we're going to do is talk about what is the definition of function notation. You don't need to write this all down, but just be aware of what is function notation. Some sets of ordered pairs can be described using an equation. When the set of ordered pairs describe an equation satisfies that vertical line test, then we say that we can write it as function notation. So this represents this blue f of x. And what we do is we input numbers in for x. So we say f of 1 equals, and we substitute 1 in for x. We say 5 times 1 plus 3. And we're going to get some numbers out that will be our output. So here's an example. This is what I do want you to write down. We want to evaluate this function for f of 0, f of 1, f of 2, and then we'll just try a few more, f of x plus 2 and f of t. So if we give you an equation that looks like this, y equals 3x plus 6, you can also rewrite it as a function where you drop the y and replace it with f of x. And then this right side is still the same. What we're going to do is we're going to substitute the domain in for x. So we say f of 0. And now let's go ahead and do that. So we say f of 0 is 3, replace the x with 0, and then simplify it. So now 3 times 0 is 0, plus 6 is 6. So f of 0 is 6. F of 0 equals 6. If you were to go out and graph that as an ordered pair, it would be 0, 6. Now let's evaluate for f of 1. So we're going to say f of 1 is, replace that x with 1, and now simplify it. 3 times 1 is 3, plus 6 is 9. So we say then, f of 1 equals 9. As an ordered pair, it would be 1, 9. Now let's substitute f of 2. So replace the x with 2. So 3 times 2 is 6. 6 plus 6 is 12. So f of 2 equals 12. As an ordered pair, it would be 2, 12. So what we could do is we could go out and graph these 3 ordered pairs, and what they do is they will construct a line for us. Now let's just do a couple more. These will not give us ordered pairs, but we'll just practice doing some more evaluating. So in this one, we're going to replace the x with x plus 2. That's where we replaced. And now what we have is an expression. So we need to simplify this by distributing the 3 through. So 3 times x is 3x. 3 times 2 is 6. And then we have that 6 at the end. So 6 plus 6 is 12. So what we have is an expression of of 3x plus 12. The last one is just evaluating the expression for f of t. So replace that x with t. And again, we have an expression. Our last example here in this slide is we want to evaluate for f of 2 and f of negative 2. So what we have is a function. If it were not a function, we would just replace that y with 3x squared, or the right side with 3x squared plus x. So let's start with the first one, f of 2. Remember, we're going to substitute 2 into here and 2 into there. So we say f of 2 equals 3. Now what's going to go in there? Is the 2. It's going to go into here and there. So I have a 2 replacing the x and a 2 replacing the x. And now we do our orders of operation. We do our exponents first. So 2 times 2 is 4. And now 3 times 4 is 12. 12 plus 2 is 14. So f of 2 is 14. That would be an ordered pair on our graph. So as an ordered pair, it would be 2, 14. Now let's see what happens when we substitute f of negative 2 in. So f of negative 2 now we're going to substitute negative 2 into here and negative 2 into there. Do our orders of operations. Negative 2 times negative 2 is 4. And then 3 times 4 is 12. Plus minus becomes a minus 2. And then 12 minus 2 is 10. So f of negative 2 is 10. As an ordered pair, it would be negative 2, 10.